Well, hello and welcome back again. Here we are. Seems like we're doing a lot of this online stuff. We are on section 18, manipulating equations. So, in the last section, what we looked at was how to actually decide which utilization we were going to use, whether it was a confidence interval level or if it was a actual test for hypothesis. And in section 18, we're going to cover that a little bit more. So in section 18, it says, in many cases, a researcher is interested in gathering information about two populations in order to compare them. It says the comparison is done through hypothesis testing. So when we're comparing two things, we're definitely hypothesis testing them. We're not looking for an interval with two separate things. The first step is conducting this hypothesis test is to write the null. So we have to write the null. Remember, the null is nothing's going on. And in addition to that, we need the alternative hypothesis. Through equation manipulation, the null and alternative hypothesis can be written in multiple ways. It says the focus on this lesson is how to manipulate these equations. Let's first assume the research is comparing one population proportion compared to a second population proportion. The following table shows the difference combination of the null and the alternative hypotheses when we're dealing with proportion number 1, or P of 1, and proportion number 2, or P of 2. I can change color right there. Nice. Or a second one, which is P of 2. Okay? All right, let's continue on. So in these particular ones, we have a left tail test here because in the null hypothesis, where P of 1 equals P of 2, nothing's going on. But P of 1 is definitely less than P of 2, giving us a left tail statistic. We're looking for a statistic out here which we would find unusual. In a right tail test, we're looking for something greater. And in a two tail test, we're looking for either less or greater. Now remember that if you test and you get a negative value, the value will be left tail. And if you get a positive p-value, well, then the positive value is going to be right. Important to designate between those two things. In order to compute these statistics and hypotheses, we need to know the null, and then we need to find the value to manipulate the null hypothesis equation. So for instance, if P1 is given to be equal to P2, and we subtract P2 from both sides of the equation, then what we wind up with is a equivalency statement right here, where P1 equal P2 is the same as P1 minus P2 equals 0. Why do we like to see that? Well, if I see 0, then I can see that my center hypotheses, if you will, or my value that I am centering up around is actually 0. And I know that because P1 minus P2 equals 0, so therefore my value in the center, and get over here, my value of the 0 is equal to 0. So what is the null hypothesis? Well, my null hypothesis for this particular statement is, or the null value, is 0. Remember that when we do our distribution and we center up, we're centering up not around the test statistic, we're centering up around the null hypothesis. It says, now let's work on manipulating the alternative hypothesis and set each of the following statements equal to 0. I'm going to try and do this on the board itself because I think I can handle these. So again, this P2 wants to come over to the side with this P1. So we're going to keep P1, we're going to subtract P2, and we're going to still be less than now 0. So the subtraction of P1 minus P2 is going to be less than 0, and I know right away, for instance, this is going to be a left tail test. It's less. On my second one, my P1 value, I'm going to subtract my P2 value, and I'm looking for a greater than situation. It's going to be greater than 0. I'm looking for a positive number. I know I'm looking for a right tail test. And lastly, P1 not equal to P2, and it's just a statement. That's all this is. We would never write this in H sub O, because remember, we don't use non-equal stuff in H sub O. Matter of fact, none of these are H sub O, but it could be an alternative. And in that alternative, we would say the alternative is P1 minus P2, whatever those values are not equal to 0, meaning two tail. Move down to the student exercises, and I am going to switch over to my document camera in student exercises. I'm going to move around a little bit here for you. So when we speak of these particular values and we speak of what's going on, and I'm going to drag this up so you can see it a little bit nicer right there, make it a little larger. When we look at these exercises, it says, suppose, I'm going to scroll up so everybody can read it. Suppose the Acme Drug Company develops a new drug designed to prevent colds, and the company states the drug is equally effective. Okay, well, that's a large statement right there. And when we say that they are equally effective for men and women, we're not saying that one is greater than the other. We're not saying that one will design more than the other. We're just simply saying that one is the same or equally effective. Okay, so don't take it for anything other than what it is. It says the test claims to choose by random sample of 100 women and 100 men, so we have equal N values on both. At the end of the study, 38% of women and 51% of men. Okay, so first of all, let's write those two statistics. Our p-hat value of women, which could be p of 1 or p of 2, but I'm going to write p-hat of women, is 38% or 0.38. And my p-hat, my statistic given for men, is 51% or 0.51. So if I'm writing a statement, H sub O, then H sub O says nothing's going on and the proportion of women is equal to the proportion of men. And my statement is, okay, well, 0.38 is equal to 0.51. And remember, if I manipulate that statement, 0.38 minus 0.51 equals 0. Remember what we're speaking of when we take these assumptions and when we do these things. Remember our H sub A, and right now we're just calculating is all we're doing. H sub A says that the p-hat of women, or excuse me, not p-hat, the proportion of women is not equal to the proportion of men, which leads me to say the proportion of women minus the proportion of men is not equal to 0. All we're doing is defining the appropriate parameter and stating the hypothesis test for these. Taking it a little far by having numbers, but that's okay. To set each hypothesis equal to 0 and find the null. Well, I kind of already did that here. I set it equal to it that the proportion of women minus the proportion of men equals 0 for my H sub O, and my H sub A, the proportion of women minus the proportion of men, did not equal 0. I know it's a two-tail. And I know it's a two-tail because of the not equal in the alternative. It says that the researcher can also test one population mean compared to a second population mean. So now we're going to talk about a mean. The following table shows the different combination for null alternative hypotheses when comparing one population mean to a second population mean. We're not used to seeing mean values set up in a population setting. And we'll bring it up right here. And we'll talk about it for a second. So these hypothesis testings often can put our mean values into a table. And it just clearly says here the girls, okay, the sample size is 9 and the average number is 2. Okay. It's not a proportion. It's not the 2 out of 9 we're talking about. It's just the number 2, or it's the number 3.2. It's the actual values that we see when we're talking about the table and the different things. So let's run through the question. Let's see what the question wants from us. It says, define the appropriate parameter and state the hypothesis for testing if the study provides evidence that the mean amount of time boys and girls aged 7 to 11 play sports each day differs. We're just simply looking to see if we have a difference of what's being calculated. And again, it's going to be a little easier for me just to write over here, so I'm going to do that. So in my first example, so first thing I'm going to say is, okay, what do I know here? So first of all, I know X bar of girls, that's the statistic that I'm given for girls, is equal to 2. And I get that from right here. And I know the X bar given for boys is equal to 3.2. And again, that's given right here. I don't want to divide that because I don't want a proportion. I want a mean value. Well, remember what H sub O would be here. H sub O would be that and remember we use the mu value of girls is equal to the mu value of boys, which is the same thing as saying that the mu value of girls minus the mu value of boys will be indifferent. It'll be 0. H sub A is going to say that the mu value of girls, and I'm going to go right to the subtraction one, minus the mu value of boys will not be equal to 0. It will not be the same. Now, if I used my statistics over here and I started calculating a test, that's to say that something subtracted from something is going to not equal 0. And remember, we just don't throw these numbers into here. Okay, we have to do a test and define them. Right now, we need to define this, and we need to define our points of interest. Set each hypothesis equal to 0 and find the null. Again, got ahead of myself, and there it is right there. This is the original statement at the top. This is set equal to 0. They are equivalent to each other. This is directly to set equal to 0. In section 19, we'll actually utilize this information, and we'll come back and do some calculations of testing. Stay tuned.